Greetings, everyone. My name is Lee Natero, and this is Instructional Strategies to Promote Reasoning and Communication in Statistics. My name is Lee Natero, and I currently teach at Moravian University in Bethlehem, Pennsylvania. If you have any questions for me after viewing the session, I would encourage you to reach out to me at the email, which you can see on your screen, or you can also contact me on Twitter. My Twitter handle is mathteacher24. So what are our goals for this presentation? Well, in this presentation, you're going to learn about 4 different instructional strategies for teaching reasoning and communication in statistics. The first one we're going to talk about is error analysis. We also have peer critique, building the model solution. Those 3 strategies are from the AP Statistics course and exam description. And then we have this one, which is not from the AP Statistics course and an exam description, called a stand and talk. And I'm going to talk about a virtual variation that I've used called a chat explosion. And in this presentation, we have a bonus strategy known as a Quickwrite. So why would you want to use instructional strategies to promote reasoning and communication in statistics with your students? First, it creates a willingness in students to share in front of their peers as they learn. They're less afraid about being wrong and right, and they're willing to learn from their mistakes. These strategies promote verbal and written communication around statistics concepts, and these strategies help to build a culture of collaboration where mistakes are valued as part of the learning process. So let's talk about the first strategy, which is known as error analysis. In this instructional strategy, you give students an existing solution and have them identify and describe where the errors have occurred. So here's an example that I've used with my students. Lisa is a good free throw shooter. She has an 80% success rate with having the basketball going into the basket, and she tries to make 3 free throws. So there are 3 questions here. I'll give you a moment to read the questions and check out the answers and see if you can identify where the error occurred. I would encourage you to pause the video at this time. So this is a binomial probability situation. The probability of success is 80%, the probability of failure is 20%, and we have a fixed number of successes. Parts A and B are correct. Where the error occurred is in part C, where the student misunderstood at least 1 as exactly 1 and exactly 1 on the first attempt. So the probability that's shown is the probability of a success followed by 2 failures. Let's take a look at an example that is definitely an AP statistics type of an example, doing a hypothesis test. When I give this type of example to my students, I'll often tell them that there are 5 errors, 4 errors, however many errors are in the problem, so they can try to find that many errors. And then I usually give them about 10 minutes or so to work through those errors with a partner. So at this time, you might want to pause the video and see if you can find the errors for yourself. So here's the first error. The equal sign should be in the null hypothesis, the greater than sign in the alternative hypothesis. We also know that both of these numbers should be the same. In this case, it should be 0.37. The large counts or normal condition is met not because n is greater than 30, but because n times p naught is greater than or equal to 10. So n times 0.37 is greater than or equal to 10, and n times 1 minus 0.37 is greater than or equal to 10. This is a common error students will make, this identifying the normal condition. They confuse the normality condition for working with proportions and working with means. N greater than 30 is for working with means. And then in the numerator, the subtraction is in the wrong order, which means that this should actually be a positive 0.732. So how would you use error analysis in your classroom? What are my practical tips? First, gather work from your students in 1 year and use it in future years. You could also use sample responses from released AP free response questions or your state assessment. I've even actually written up wrong solutions with errors in it, like that one you just saw. And sometimes I'll even actually write it in my own handwriting to make it look like a messy student's handwriting. Although my husband would tell you that my handwriting is naturally messy. Let's take a look at this second teaching strategy, peer critique. This is where students work in pairs or small groups to critique solutions to free response questions. So this is an example of a graph that was given to my students at Moravian University. I teach elementary statistics, and this was a set of 6 box plots showing graduation rates at colleges A through F, and the students were asked to compare and contrast the graduation rates. And so this is an example of a solution that was given to me by one of my students. They said half of the colleges have a center above 70%. Let's take a look at that. Half are above 70%. I would say that's accurate. And the other half of a center below 70%. It would have been better if they said median there, but center is okay. 4 of them have a minimum that is below 60, and all 6 have a maximum of 70. Well, all 6 definitely don't have a maximum of 70. So there's some errors there. And the 2 outliers are A's min and F's max. If we were to use the 1.5 times the interquartile range rule, so think about the length of the box plot plus half the length of the box plot, this is definitely not an outlier, and neither is this one. So my students, in terms of critiquing this, would want to talk about the evidence for center, spread, outliers, context. Right now, I don't really, other than colleges, I don't really see enough context here. And then any other comments that they might have. So what are some practical tips that I can offer you for doing a peer critique instructional strategy with your students? First of all, do a large class critique first. Focus on the work and not the student. You might want to scan student solutions and remove the student names. So you're just focusing on the student work. Give students criteria to help them with the critique. Otherwise, they might not be sure what to focus on. In the previous slide, you saw I had a list of things that they were to focus on with a place for them to put evidence. And then have all students answering the same prompt and then sharing with 2 others for feedback would be a good way to also do a peer critique. They're very used to doing things like this, most likely in their English and history classes with essays. Our next strategy that we're going to talk about is building the model solution. For building the model solution, students work in pairs or groups to assemble a sentence to represent a model solution to a free response question. This should be really quick, takes about 5 to 10 minutes to do. And here's the way this works. First, you find a model solution from an AP free response question or from your state assessment. So what is it that you want the students to actually say in the model solution? And then you're going to split that sentence or 2 sentences into pieces of 4 to 5 words in length. Then you're going to create 4 to 5 additional pieces that could be used in place of some of the pieces. These could be based on common student errors, like using mean instead of median or sample instead of population. Then you put the words from steps 2 and 3 on separate cards or pieces of paper. I actually type them into a table in Word, and I have the font be a little bit larger, and then I can cut them apart. And then I paper clip them together to hand to pairs of or trios of students. So you give the students the prompt and extra pieces of paper. You might want to tell them how many extra pieces there are. So you give them the actual pieces they'll need plus those few extras. And you might want to say, you know what, the model solution you're going to create has 5 extra pieces, which is actually what we're going to have in this example that we're going to take a look at. So Fiddle Lake is stocked with fish in the winter for fishing. It's safe to assume that the weights of the fish are approximately normally distributed with a mean length of 7 inches and a standard deviation of 1/2 inch. A random sample of 50 fish was caught, and the probability that the sample mean was less than 6.5 inches was calculated. If the population distribution was non-normal, would it still be appropriate to use the normal distribution to compute the probability? So that's the question that they're forming the model solution for. And so here are the slips of paper. And so the students need to rearrange these slips of paper to form the model solution, the solution to that question. And I let them know that there are 5 slips of paper here that they would need to remove. And sometimes they have trouble getting started, so I remind them that sentences start with capital letters and end with periods. And so the answer to the question is yes, but it's not the law of large numbers. And we're not talking about sample proportions, we're talking about sample means. And it's not about the sample size being greater than 10. It's about the sample size being greater than 30. The sample size is reasonably large at 50. We never talk about the normal distribution being exactly normal for a situation like this. It's only approximately normal, since we can't have an infinitely large size fish or infinitely small size fish. And it's not about the population, it's about the sample size. So here's what the model solution looks like. It says, yes, the central limit theorem says that the sampling distribution of the sample mean will become approximately normal as the sample size n increases. Since the sample size is reasonably large, it would be appropriate to use the normal distribution to find the probability of interest, even though the population is non-normal. So that could be a little bit challenging, especially for your students that are just learning the English language. So here's a suggestion for a variation on the strategy of building the model solution. Have the full model solution, but leave 3 or 4 blanks for students to complete, or possibly give them multiple choice options for what might go in the blanks. So here's an example. We have this least squares regression line, y hat equals 5.2 minus 2.3x, where x is height in centimeters and y hat is the predictive number of steps it would take for a person to get from the library to the gym. So the blanks to fill in here are the number for the slope. And then this means that for each additional centimeter in height, the number of steps to get from the library to the gym is predicted to, and if you were giving a multiple choice option, you could give them increase or decrease, and then and you can give them the number 5.2 or 2.3. So this is building the model solution variation for your students that may struggle with the English language. We also have what is known as a stand and talk. This is a quick way for students to think about a prompt and then talk about a prompt. This concept was created by Sarah Vanderwerf, who I heard speak at NCTM several years ago, where she actually demonstrated how to use this strategy. And it's a strategy that I use with my students regularly. So a stand and talk is like a turn and talk, but better. First of all, there are no trios or opting out. You tell the students, all right, here is your prompt. I'm going to give you 30 seconds of individual wait time. And then you're going to go stand and find someone to talk to across the room. You can't talk to the person that's immediately beside you. There are no trios. So if there's an odd number of students, you'll be talking to one of the students. I would say I do not recommend this as a class opener. I've tried it as a class opener and it falls flat, probably because the students are not warmed up yet. Their brains have not been thinking about statistics. And my last tip for doing a stand and talk is to keep the momentum, stand and debrief. So talk about the prompt while students are still standing up out of their seats. As soon as they sit, you've lost that momentum. If you tend to have students that don't want to share initially here, then you might want to actually talk to a pair of students if you're not having to be a part of the stand and talk because you have an odd number of students. If there's an even number of students and you can walk around the room, listen to what they're saying. And if you have a pair of students that you think, you know what, they've got something that I want them to contribute and share, tell them that you're going to call on them to get the ball rolling. Just giving that heads up makes it a little less threatening when you actually call on them. So here's an example of a stand and talk prompt. We've got a mosaic plot here of the class of travel on the Titanic, and we can see the light blue representing that the passengers died, the darker blue that they survived. So what story does this graph tell about the people who were on the Titanic? And I don't even explain the labels or the key to them. I just ask them, what story does this graph tell about the people who were on the Titanic? So take a moment to think about that. And I want to point out that this mosaic plot is a little bit different than just your traditional bar graph, because it shows us that the third class passengers were actually about half of the passengers on the ship. It wasn't split equally between first, second, and third class. And with a traditional bar graph or a segmented bar graph, we would not notice that. So the mosaic plot gives us that additional piece of information. Here's another example of a stand and talk I did with my students. We were reviewing our unit on experimental design, and I asked them, what vocabulary words aren't you sure about? What words do you remember that they exist, but you don't know what they are? And the students gave me a list. And then rather than saying to them, okay, I would like you to ask me about these words, which ones don't you understand? Right? I would have heard crickets if I asked that question. So instead I said, okay, I want you to pick out words that you don't know or you're not 100% sure about. And I gave them 30 seconds to think about those words. And then I said, okay, we're going to do a stand and talk. Go and stand and talk with somebody about the words that you're not sure about. And as soon as I did that, everybody was talking about the words that they weren't sure about. It was very freeing for the students, because then when I said, okay, who would like to ask about one of the words that they're not sure about? Everybody was willing to talk about a word that they weren't sure about, because they realized everybody was in the same situation as them. So then somebody would say something like, I don't understand what matched pairs is. And rather than me saying, this is what matched pairs is, I called on students to explain what matched pairs are. It was very, very effective for reviewing vocabulary. So what could you do if you were teaching virtually? There was a virtual variation of this called a chat explosion. You may also know this as a waterfall. This is a quick way for all students to have an opportunity to think, write, and share. As I mentioned, it is a good alternative. However, there's no sharing with a partner prior to typing a response in the chat. And for that reason, sometimes the prompts aren't quite as high level because they don't have a chance to chat with somebody about it. So here's the steps for a chat explosion. First, announce that this is a chat explosion. Announce before you even give the question or the prompt that it's a chat explosion, which means the students are not going to hit enter until you give them the directions to do so. You want to make sure you allow the students to have adequate time for thinking and typing. You may even want to type a response yourself so you can see how long it takes to type a response. Make sure you embrace the silence at some point. Don't talk, because it's very challenging for students to think and type while they're listening to you talk. And then after they've had some time to think and type about the prompt, tell them, let the chat explode. And you'll see all the responses that come up in the chat. And then you're going to summarize what you see in the chat. What are common responses? What are some responses that are a little bit different? Highlight some of those responses. You may even want to just give the students 30 seconds or so, or maybe even a minute, to read through the chat for themselves. So here's an example of a chat explosion prompt that you could give. You can even give this prompt as a stand and talk. This is a photo that was given to me by Vicki Greenberg, who is an AP statistics teacher. So which of these scatter plots, 1, 2, 3, or 4, doesn't belong? Which one doesn't belong is a common prompt that's given in math class, but rather than calling it which one doesn't belong, I think we should say which one is different, because belonging, it seems like something's out, something's wrong, rather than which one is different, right? We celebrate differences. So which one is different here? 4 is different because it's got a negative relationship. 2 is different because it's curved. 1 is different because it's a very loose linear relationship. The points aren't clustered very tightly around a line or a curve. And 3 is different because of the outliers. Here's another chat explosion prompt you could use. What do you notice? What do you wonder? And you don't even have to explain the graph to the students. The students can see what's going on the graph. They'll notice that as average SAT writing scores go up, the percentage of 3s, 4s, and 5s a school has on the AP exam tend to go up as well. And this data, by the way, did come from public schools, public and private schools, actually, in the state of California. This was from our random sample of schools. So now let's talk about this bonus strategy known as a Quickwrite. So with the Quickwrite, students write for a short, specific amount of time on a designated topic. And one thing I will say is you don't need to provide feedback on every single piece of writing that students do. It's important to have them write frequently, but you don't have time to read all their writing. But it's important to have them write, even if it's just a few sentences, to answer a question like this one. Which of the following would provide you with more evidence that a coin is not a fair coin? 6 heads in 10 flips or 8 heads in 10 flips? So it's just choosing one or the other, and then why? And I will say that this particular prompt is used to introduce my students to the idea of statistical significance, because there's an intuitive sense of which is right and which is wrong here, or I should say which one gives more evidence. So 6 out of 10, that's probably not enough evidence because that's pretty close to 50%. 8 out of 10 seems like it's a little less likely if the coin was fair. So it seems like 8 out of 10 would give us more evidence. Well, what about these 2 coins? Right? What if I flipped a coin and got 8 out of 10 flips? Sorry, 8 heads in 10 flips, or 80 heads in 100 flips? Which one of those is going to provide you with more evidence that the coin is not a fair coin? And here, the sample proportions are the same. It's that the fact that the sample size is larger, those 80 heads and 100 flips, that seems to not be very likely if the coin was a fair coin. So just having the students write a few sentences to describe their thinking is a good way to promote that reasoning and communication that we need in statistics. So just some final thoughts as we wrap up. First of all, make sure you encourage writing with your students, even if it's just writing a few sentences of their own every day as part of your class. Make sure you give sufficient time for thinking, whether it's thinking and then writing or thinking and talking. And make sure you let students talk and describe what they're seeing and what they're noticing and wondering relative to the statistics that you're studying. And make sure you value mistakes as a part of the learning process. This was a burst session, so it was designed as a 30-minute session. And had we been live in Atlanta in September, this would have definitely lasted 30 minutes. But hopefully you've enjoyed this session. Hopefully you've gotten some new ideas to help you promote reasoning and communication in statistics. If you have any questions for me, please feel free to contact me, Lee Natero. My email address you can see on your screen, nateros@moravian.edu, or reach out to me at Twitter, mathteacher24.